We often think about cities growing outwards or upwards, reaching for the sky with towers and new suburbs. But what if the real frontier for urban development isn't actually up there, but right beneath our feet?
Yeah, it's this whole hidden world down there, full of incredible potential, definitely, but also some really surprising challenges we rarely talk about.
Exactly. It's a whole other dimension to urban life, and one that feels like it's becoming more and more critical.
Absolutely. I mean, you've got complex infrastructure networks we rely on every single day, innovative energy systems, and yeah, even places where people are choosing to live underground.
And that is precisely what we're digging deep into today. We've pulled together this stack of your sources, articles, research bits, some fascinating notes exploring this world of sustainable urbanism.
Right, specifically looking at how we can leverage underground space and smart energy solutions to build more resilient cities for the future, really.
So our mission here is basically to unpack all this material, find the key insights, the really essential stuff, and understand why thinking downward seems to be shifting from like a niche idea to something pretty fundamental for our urban future.
Okay, let's do it.
So let's jump right in. What secrets does the subsurface really hold? What can we learn from, say, history, and what are these newer projects telling us?
Okay, well, let's start with the basics. Why are cities increasingly feeling pushed to look downwards? The sources point to some really stark pressures.
Like what?
Well, first off, just rapid population growth. It keeps piling more and more density onto the surface.
The physical space crunch.
Exactly. And beyond just that, there are significant environmental impacts from all this surface density. Plus, climate change itself.
Which could make the surface less predictable, maybe even less hospitable over time in some places.
Precisely. So when you factor in all those pressures, that unused space underground suddenly looks like a profoundly valuable resource.
It really does. It's often overlooked land, isn't it? And it can offer completely new functions without needing us to, say, destroy heritage buildings or mess up the existing surface environment.
And the sources make a really strong case that integrating this underground space use isn't just about finding more room. It directly helps cities hit some ambitious environmental and sustainability targets.
Like reducing greenhouse gas emissions.
Drastically, yeah. And look, this isn't just some theoretical concept being kicked around in academia. No, we're seeing it implemented in benchmark cities around the world right now. The sources highlight places like Helsinki, Singapore, Hong Kong, Minneapolis, Tokyo, Shanghai, Montreal, Reykjavik, Kuala Lumpur.
That's quite a list.
It is. And they aren't just thinking about underground space. They're actively weaving it into their strategic planning. They see it as key for more livable, resilient, and, importantly, inclusive urban environments.
And that links back to bigger goals.
Directly. It connects straight to the UN's Sustainable Development Goals, particularly Goal 11, which is all about making cities sustainable.
Okay, so that paints the picture of the big pressures and the global goals connection. But let's get into the nuts and bolts now. How is this underground realm directly tied to things like critical urban infrastructure and energy?
Right.
This concept, the sources call underground urbanism, seems pretty central here.
That's a great term for it. Underground urbanism isn't just, digging holes randomly. It's more of a holistic approach, integrating the subsurface into city planning, into design, into how the city functions.
And a key practical application seems to be these multi-utility tunnels.
Yes, exactly. Yeah. The sources talk a lot about those.
What's fascinating is the idea of housing all those different networks together. Underground electricity grids, district heating pipes, telecom cables, water supply.
Consolidating them into one shared tunnel. Think about the implications for just day-to-day city life.
Well, the advantages for operation, maintenance, safety, they seem pretty obvious when you put it like that.
Incredibly evident, right. You're not constantly ripping up streets or blocking traffic every time one specific utility needs access or repair.
That drives me crazy.
Everyone hates it. Yeah. And the sources specifically point to examples that are already working, like tunnels in Geneva, Stockholm, and Copenhagen.
Okay, so that's consolidating existing stuff. But underground space is also proving critical for entirely new systems, especially these large-scale district energy networks.
Absolutely. These systems for heating and cooling whole neighborhoods or even bigger parts of a city, they can be way more efficient than relying on countless little individual building systems.
Makes sense. And they help manage variability.
A huge benefit. Because they serve so many users, they're inherently better at sort of smoothing out the bumps, compensating for fluctuations in energy supply and demand, which is a big deal with modern grids.
Which ties directly into integrating renewables, I guess.
Exactly. Underground space is key for seamlessly connecting diverse renewable sources, geothermal, solar thermal, wind, biomass, even waste energy into these urban energy systems on a really large scale.
The sources mention geothermal quite a bit.
Yeah, it's a compelling example. They talk about really creative uses like repurposing old abandoned mine shafts for heating and cooling. There's an example in Heerlen in the Netherlands.
Oh.
Or developing entirely new large-scale geothermal district heating networks like the one they built in Monterey, Italy.
And then there was this more advanced concept they discussed. Polygeneration. Sounds complex.
It is a bit more advanced, yeah. But the core idea is about simultaneously producing more than two useful outputs from one system.
Okay.
So most commonly, that's electricity, heat, and cooling, often using things called absorption chillers. Sometimes it can even include producing materials.
Electricity, heat, and cooling from one system. That sounds incredibly efficient.
It is. The sources cite primary energy savings of around 35% compared to just having conventional separate systems for everything.
35%. What does that mean in the real world, practically?
Well, it means a drastic cut in energy use and the emissions that go with it, especially for big energy users. They give examples like polygeneration systems providing efficient cooling in Cerdanyola del Vallès near Barcelona.
Okay.
And for really critical infrastructure like St. Olav's Hospital in Norway. They also mention biogas polygeneration plants, and these cleverly use waste materials, adding another layer of sustainability. Pretty smart.
Of course, when you start talking about integrating renewables like solar and wind, which aren't always on,
Right, the intermittency issue.
you run straight into the challenge of energy storage. And guess what? Underground space pops up again is crucial.
Absolutely crucial. Whether you're talking about storing huge amounts of hot water for large solar thermal systems or maybe chilled water for big cooling networks.
Or the really tricky one, storing energy from wind farms. And they mentioned Dundalk, Ireland.
Yeah, that's a tough one. But for all of these, the stable subsurface environment provides the sheer volume you need, and often natural insulation, too.
So all of this, it really underlines something the sources kept emphasizing.
What's that?
That subsurface planning simply has to be an integral part of overall urban land use planning right from the start. It can't be an afterthought.
No way. It means developing new technical solutions, sure, but also setting up clear regulations like these formal master plans for underground services they mention. You need a framework.
Okay, shifting gears slightly. Beyond just infrastructure and energy grids, the sources also explore using underground space for actual living homes, communities.
Yeah, which sounds radical maybe, but it's not a totally new idea. It actually has really deep historical roots.
Right, they mentioned ancient humans, using Ks, obviously, but also settled communities like Çatalhöyük in Turkey thousands of years ago.
Edible place.
And those amazing historical Icelandic turf homes, the Torf Bear. Brilliant examples of what they call vernacular architecture.
Totally. Built specifically for thermal protection, using local materials, stone, wood, turf, soil, things with low embodied emissions, and designed to just blend right into that harsh landscape. Very clever.
And modern underground or earth-sheltered homes, they carry forward some of those basic benefits, but add new ones too.
Definitely. For one thing, they often need significantly fewer building materials because there's just less surface area exposed to the weather.
Which means lower maintenance costs over time, I suppose.
Exactly. Plus, they are inherently incredibly resilient. Earth-sheltered buildings offer fantastic protection against high winds, fire.
Earthquakes too.
Often more resistant to earthquake damage, yeah. They just provide a much more secure environment when extreme weather hits.
But maybe the most compelling benefit they talked about is the energy efficiency. It sounds dramatic.
It really is. The stable temperature of the ground provides what's called geothermal mass. Essentially, the Earth acts like this massive stable temperature battery.
Okay.
So the house stays naturally cooler in summer and warmer in winter just through basic heat exchange with the Earth around it. The sources suggest this could potentially save around 80% on typical heating and cooling costs.
80%. That's not just saving a bit of money. That fundamentally shifts the economics of housing, doesn't it?
It really does. And the sources even mention that if you incorporate smart passive solar design as well, you could potentially get those energy bills right down to zero.
Wow. And there's a noise insulation bonus, too, making them surprisingly quiet inside.
Very quiet. And you see these ideas applied not just in single homes, but in whole urban complexes, too.
Like Montreal's RISO.
Yeah, highlighted as the largest underground pedestrian network connecting huge parts of the downtown core. Helsinki, too, they already have extensive underground stuff. Swimming complex, shops, a hockey rink.
And big plans for more.
Ambitious plans for 200 more buildings underground. And Singapore is actively exploring broad underground use, extensive district cooling, transport lines, you name it.
And I was really struck by that little detail from one source about people visiting underground houses for the first time.
Yeah.
And being genuinely amazed at how big they feel inside. It just completely flips that common assumption that they'd feel cramped or dark.
Good design can absolutely overcome those perceptions. But, getting to that point, building and living underground, it definitely comes with its own specific set of challenges.
Yeah, the sources are very clear about that. One big historical problem they point out is just the ad hoc way things have been built underground in the past.
Right. Separate companies or sectors just digging where they need to without much coordination. That desperately needs to change.
We need synergy.
Absolutely. To get truly rational use and successful integration into the city plan, you need genuine synergy between all the different disciplines and stakeholders. Public admin, private developers, and users. Everyone needs to be involved.
And the sources emphasize the crucial role of urban design departments here. They need to take the lead.
Yeah, in providing clear guidelines, coordinating projects, ensuring quality in these underground urban landscapes, thinking about human well-being, comfort underground.
And making them easy to navigate. Legibility, they called it.
Exactly. Making potentially complex subterranean spaces easy for people to understand and move through. That's vital.
Then you have the basic engineering hurdles.
Oh yeah, site selection is absolutely critical. You have to really understand the soil, the topography, and especially the water table. That's huge.
And the design itself needs to be smart about light, ventilation, moisture control.
All of that. Getting permits can be tough too. Codes might be strict or maybe non-existent for these structures. Community concerns can be high.
Excavation safety, obviously.
Paramount. And building foundations and structures strong enough to handle the pressure of all that earth above.
And based on the anecdotes in the sources, one thing really stands out as critical, and sometimes, well, a real pain point.
Let me guess. Water.
Bingo. Waterproofing and drainage. Keeping moisture out and managing water flow around the structure seems absolutely non-negotiable.
This is where those vivid, real-world stories from the sources really bring it home, don't they?
They really do. The difficulties people have had dealing with leaks in underground homes, descriptions of waterproofing just failing, leading to stalactites forming inside the house.
Nightmare fuel.
Totally. And the huge challenge of even finding where the leak is coming from to fix it, let alone the insurance nightmares with pre-existing problems.
Yes.
The sources also mention ongoing issues with humidity sometimes, and even unexpected problems with heating or cooling efficiency, despite good design intentions. It just hammers home the need for really robust drainage, like those swales they mentioned.
Right, those shallow channels specifically designed to guide water away. Absolutely vital.
And speaking of hidden problems, the sources introduce this really significant, often totally unseen threat they call underground climate change.
Yeah, that's a fascinating and frankly worrying concept.
Underground climate change. What exactly causes that? How's it different from the regular urban heat island effect we know about on the surface?
Well, it's related, but it's specifically the rising temperature beneath cities. It's partly caused by the surface heat island effect, transferring warmth down, sure.
But not just that.
No, also, significantly, by heat leaking directly from underground infrastructure itself. Think furnaces, boilers in basements, subway trains generating heat, cars and underground parking garages, even just the body heat from lots of people in buildings.
And that Chicago study was pretty stark. Finding underground temps in the Loop area were 10 to 25 degrees higher than nearby undeveloped ground.
Yeah, 10 to 25 degrees. That is a massive thermal difference down there.
And this isn't just some abstract number changing.
No, the sources suggest the subterranean warming is actively destabilizing building foundations. It seems to be a particular risk for older buildings in dense areas waterfront cities, or places built on softer soil or landfill.
Feels like an unseen crisis potentially undermining the very ground our cities stand on.
It really does. A hidden threat.
So, okay, given these pretty significant challenges, the water, the heat, what do the sources propose as the key ways to mitigate them?
Well, for underground homes, ensuring plenty of natural light, clever use of windows, skylights, that's vital for making them comfortable living spaces.
But the big one,
Fundamentally, it comes back to robust, high-quality waterproofing materials. That has to be non-negotiable. And designing genuinely effective drainage systems around the structure, really learning from those painful real-world mistakes.
makes sense. And for tackling that underground climate change issue.
Their recommendation is basically to insulate underground enclosures better. Basements, parking garages, even the underground levels of hospitals and schools where lots of mechanical systems are often housed.
Why there specifically?
Because they reckon a huge chunk, maybe 70–80% of a building's total heat loss actually emanates from its underground sections. So insulating there could make a dramatic difference, both for the building's energy efficiency and for reducing that heat bleeding into the surrounding ground.
Two birds with one stone.
Pretty much. And on the construction side, they also stress using local, salvaged, or recycled materials where possible: earth, timber, clay, stone. These often have much lower embodied emissions than conventional modern materials.
Right, the sustainability angle again. And finally, the sources seem to stress monitoring and awareness.
Absolutely crucial. Monitoring the actual energy performance of buildings and networks using meters, collecting data, storing it, evaluating it, that's key to understanding exactly where energy is being used and lost. It allows for continuous fine-tuning.
And getting the public on board.
Vital. Engaging people through awareness activities. They mentioned that Ice Cube Bet passive house demo as an example. That's how you gain acceptance and encourage people to participate in hitting those efficiency goals.
So, bringing this all together then, the sources paint a picture of real progress happening, but it seems largely driven by collaboration.
Very much so. Initiatives like those EU Concerto projects get highlighted as these great test beds for new approaches and solutions. They focus specifically on transferring knowledge and replicating success by involving everyone: city authorities, developers, citizens.
It sounds like overcoming the obstacle, technical, planning, even psychological, really does need dedicated people finding ways to share ideas and expertise.
You need those platforms for exchange, definitely. And when it's done right, when projects truly integrate that underground potential with smart, holistic energy planning,
Then what?
then the sources show that cities can achieve seriously ambitious energy and emission reduction targets, goals that might otherwise seem completely out of reach.
It feels like we're in this interesting phase, learning from both the distant past, like those turf houses, and the immediate present.
Applying timeless design principles from vernacular architecture, adapting them for future climate scenarios, and layering on all the modern engineering and planning innovations.
It sounds like building a truly sustainable future, especially in our crowded cities, absolutely involves this continuous process. Learning, monitoring, refining how we use that space below our feet, responsibly and intelligently.
Couldn't agree more.
So we've journeyed from the immense pressures pushing cities downwards, explored the innovative ways we're using that space for essential infrastructure, critical energy systems, even resilient homes.
And dug into the complex, but it seems addressable challenges involved. From the engineering basics to that subtle threat of underground climate change.
Understanding these hidden layers beneath our cities, it's clearly not just interesting trivia, is it? It feels key to being genuinely well-informed about where urban sustainability and resilience are heading.
Absolutely key.
It really does make you pause and think, doesn't it? We've spent centuries reaching for the sky, defining urban progress by how high we can build. Perhaps the most responsible, the most innovative, maybe the most sustainable path forward isn't just about building ever upwards, but about thoughtfully, creatively, and responsibly building downwards too. Fundamentally changing our relationship with the ground beneath us.